Okay, so this is the video for 6-3. So when we're working with rational expressions, it's really just fractions, right? Last time we started by multiplying we started by like reducing fractions, great, looked at what it was for rational. Then we multiplied fractions and divided fractions, and we looked at what it was there. This time, we're going to add and subtract. And it's kind of weird with fractions, adding and subtracting is actually way harder than multiplying and dividing. And when we then increase the complexity and include polynomials, things do get more complicated. So how I have this set up is we're going to do a fraction practice, and then on the right, similar polynomial thing, and we'll see the connections between these things. So this is a little bit of fraction practice and also learning this new section. So to start off, when you add or subtract fractions, we always need a what? Common denominator. In this case, we have a common denominator. So what we can do is combine these things into one fraction with that common denominator, right? And so this becomes -2/6, which of course reduces to -1/3. So, but this is what happens, is when you have a common denominator, we make one big fraction with that denominator, and you take these numerators and you subtract them, right? So exactly the same thing happens here. Here we have a common denominator of 18uv cubed. And so then what we can do is we can take our numerators and subtract them. So u plus 3v minus u minus v. Don't forget that there's parentheses involved here. I can't tell you the number of even calculus students who mess this up. You have to understand that there's parentheses around here. And in particular, this matters because this -1 times the negative v is going to end up being positive v. So now we distribute. I'll actually just do that step right here. So 18uv cubed, we have to distribute in order to get rid of parentheses. Here we're distributing a 1, that's fine, but here we're distributing a -1. So this is u plus 3v minus u plus v. And in this case, u minus u, those go away, because u minus u is 0. So we get 3v plus v, which is 4v on top and 18uv cubed on bottom. Now that we have all multiplication, now things can cancel. You have to remember that when you have like a plus b over a, these do not cancel. Why? Because of the thing in the middle, right? So when you have addition and subtraction, you can't cancel stuff. You can only do that when there's only multiplication and division. But now there's all multiplication and division, so we can do this. So if we divide by 2, this becomes a 2 and this becomes a 9. This v and v cubed, this becomes a v over v cubed is v squared on the bottom. And so this is 2/9u v squared. Now, I focus a lot on restrictions in the first two sections, right? When we're simplifying rational expressions, tell me your restrictions. When we're multiplying and dividing, tell me your restrictions. Now that we get to addition and subtraction, we can kind of skip that, okay? And I'll try to be clear on that on like tests and quizzes and homework assignments. But technically u can't be 0, v can't be 0, that's still there, right? But at this point, we can start not writing that down. Okay. So The next one we have is we're adding two fractions where we don't have a common denominator, but one is actually a multiple of the other. Okay? So what you want to do when you have fractions is always think about the prime factorization, or at least finding that 12 is 3 times 4. Just remembering that. Because what that allows you to do is we can ask ourselves, what are we missing on this first fraction? Well, we have a 3 in common. They already have that in common, but we need a 4 over here. So we're going to multiply this one by 4 over 4. What that does is it makes it 8 over 12 plus 5 over 12, which, as we just learned, is 13 over 12. Now, the same thing works over here. Here, we have 3v minus 12. Always start by factoring. 3 times v minus 4. And same thing as last time, we have a 3 in common. They already have these, right? But what we need to multiply by is this guy. This has a v minus 4, so we have to multiply by v minus 4 over v minus 4. And we get 2 over 3v minus 4 plus 3v times v minus 4 over 3 times v minus 4. We have a common denominator, so we can put this together. We get 2 plus, I'm going to go ahead and distribute it in the same step, 3v squared minus 12v over 3 times v minus 4. And I do like this in standard form. I don't like that that's not in standard form. So 3v squared minus 12v plus 2. And if you want to distribute it, you can, whatever makes you happy, but I'm perfectly fine with factored form. Can we find two factors of 6 that add to negative 12? No, we can't. So that's as simple as it gets. Okay. So on these next ones, we're going to have things that are relatively prime. That means they have no factors in common. 7 is just 7 times 1. 12 is 2 times 2 times 3, right? So there's no factors in common. So what we're actually, the easiest way to do this is actually just multiply by the other thing, okay? I want to point out, over here, I could have multiplied by 12 over 12 and 3 over 3. That would have worked, right? We would have gotten something over 36 and then had to reduce. That does work, but the only time you actually want to do that is if there are no factors in common. And in this case, there are no factors in common. We just checked this. So here, what we can do is we can multiply this one by 7 over 7, this one by 12 over 12, and get 12 over 84 minus 77 over 84. 12 minus 77, last I checked, is negative 65 over 84. Let's see, I'm just checking this. 5 is 5 times 13, and 84 is 2 times 2 times 3 times 7, so no common factors. That's as simple as it gets. Okay. What did I do to check that, by the way? I did the prime factorization of each. And I could see that none of these have any common factors, so it can't be reduced. Okay, so on this side, we're also going to have something that's relatively prime. These are both already factored. We can't go down any further. So what we're going to do is we're going to multiply this side by p minus 1 over p minus 1, and this side by 7 over 7. And what that's going to get us is 8p times p minus 1 plus 8 times 7 all over 7 times p minus 1. So that would be 8p squared minus 8p plus 56 over 7 times p minus 1. And for good measure, these all do have a GCF here. So we should factor just to make sure nothing's going to cancel. And let's see, are there any two factors of 7 that add to -1? No, that's prime. So this would be the factored form. Honestly, yeah, I want to see this. If there's a GCF here, I was just thinking if I would accept this on a test or takeoff point. I probably wouldn't. I'd probably go, you can factor GCF, but I'd go okay. But it's good practice to factor out a GCF and just to see if these are going to have anything that we can reduce. Okay, and the last one is where we actually want to use our LCM to be able to do this, to get our common denominator, because I could do 56 times 42. River, you got that off the top of your head? No, that's not the top of your head. That's called a calculator. But what is 56 times 42?
2,352.
Yeah, so something in the 2,000 what?
2,352.
2,352. I don't want to do that, okay? Now, again, you could multiply this by 56 over 56 and 42 over 42, get these giant numbers and reduce that, but it's much better to think about this in terms of prime factorization. These are the building blocks. So 42 is 6 times 7, which is 2 times 3 times 7. 56 is 8 times 7, which is 2 times 2 times 2 times 7. So here's the trick. These both have a 2 and a 7 in common, right? They already have that. So what does the right side need that the left side doesn't have? The right side needs 2 times 2. So we multiply this by 4 over 4. The left side needs a 3. So we multiply this by 3 over 3. So these are much nicer numbers where you get 15 over 3 times 56 is 150 and 18, which is 168. Plus 20 over 42 times 4 is also 168. 160 plus 8. And so this reduces to 35 over 168. Now, I would like to point out that we actually have the prime factorization of, well, 35 is easy. That's 5 times 7. We have the prime factorization up here because 168 is 2, 2, 2, 7, and a 3, or 2, 3, 7, 2, 2. So this is 2 times 2 times 2 times 3 times 7. And so what we can do is then we can factor this out by getting rid of the 7 they have in common, and we'll be left with 5 over 222 is 8 times 3 is 24. Okay, so here's going to be a similar one where there's going to be a common denominator or a common factor. So this is 3 times r. Here, a 6 can come out. So I'm going to factor out a 6 as 2 times 3, being left with r squared minus 5r plus 6. So that is 2 times 3 times r minus 6, r plus 1. I did that wrong. Positive 6 that add to negative 5 is r minus 2 and r minus 3. So what we have in common is a 3, let me do this the same way, a 3 and an r. We do not need to, we don't have the r in common, sorry. So we have a 3 in common. That's it. And that's kind of gross. I was hoping that would be more helpful. But what do we need to multiply over here by? We need to multiply this by r over r. We need to multiply this by 2 r minus 2 r minus 3. And what we'll end up with is, see, 4 times 2 is 8. And then we'll have 8 times r squared minus 5r plus 6 over this ugly fraction, 6r, r minus 2, r minus 3. This side is going to be r times r plus 4 over 6r, r minus 2, r minus 3. And what that's going to get us is, when we distribute and combine like terms, we'll get 8r squared minus 40r plus 48 minus r squared minus 4r. Don't forget to distribute the negative r. Obviously. Over, I don't want to write this again, so I'm going to duplicate it and bring it on down here. And then we combine like terms, we get our answer, which is 7r squared minus 44r plus 48 over, again, don't want to write this, duplicate. Oh no, it's a different color. Booyah. All right, and I'm not worried about factoring that. So that is the end of this section.
They got a new book.